This is Mr. Green, and this is another in my series of AP Statistics videos that I'm making for you. Today we're going to be looking at 9.2, which is the two proportion test and inference area and confidence region. Golly. Significance test and confidence region. So we're looking at these things: confidence intervals and significance tests for two proportions. Okay. So what do we think? One thing you got to keep and remember and understand about this is there's a different way of doing things for the confidence interval and for the inference and for the hypothesis testing. For the hypothesis testing, we're going to be using a pooling approach, and in the confidence interval, we don't. Okay, so we got to be very careful with these things to make certain that we know what we're doing. So when you're comparing two proportions, use a normal approximation. You always need to make certain that n times p and n times 1 minus p and n2 minus p and n2 minus 1 minus p2 are all greater than 10. Okay, then what p1 and p2 are estimates for p1 hat and p2 hat. Okay, so you got to make certain that you've got large samples. Okay, all samples times the proportions have to be greater than 10. Okay, uh, basically the standard error is shown right here in this equation. You add the 1 plus minus, or the p hat, and the 1 minus p hat, and divided by n, and you add that to the p2 times the 1 minus p2 hat divided by n2. That gives you the standard error. Okay, having said that, what we're going to do is we're going to multiply that standard error by the z-score so that you can find the confidence interval. You'll take the difference in the two p hats plus or minus z star times that standard error. Okay, let's try one here, see what we come up with. Okay, here we've got a survey that was collected over two cities, City A and City B. Okay, and that they're voters in those cities, and they're just looking to see if they have the same opinions between the two cities. Okay, and they want to find a confidence interval for the difference between the proportions, the population proportions in the two cities, and that's the standard error needs to be shown. So what we're going to do is we're going to say P1 hat is equal to 463 divided by 615. Where did I get those? Right here. Okay, so P1 hat is 0.75. P2 hat, we're going to take this, 403 divided by 585. That's 0.69. So we're going to we need to show that everything is greater than 10, so we take 415 times 0.75 and 615 times 0.25. Those are both greater than 10. And 585 times 0.69 and 585 times 0.31. Again, both greater than 10 without any problems at all. So we can proceed. No problems with us proceeding on this one at all. So I'm now going to find the standard error. I'm going to take the square root of 0.75 times 0.25. What is that? Well, this is that p hat 1, and this is 1 minus p hat 1, divided by 615. And I'm going to take 0.69 times 0.31 divided by 582. Again, p hat 2 divided by 1 minus p hat 2. Okay? Multiply that whole thing together, take the square root of it, and I get 0.26. So if I were building a 95% confidence interval, I would take 0.75 minus 0.69 plus or minus 1.96 times 0.026. And what I get is this 0.009 and 0.111. Now, the way you would take this and do an analysis of it is you'd look at it and say, since 0 is not in this interval, there is evidence of a difference. So you would say there's a difference in the way the voters are looking at this proposition in these two cities. Okay, not much of one. Okay, but there is still a difference between them. Okay, so having done that, let's look at a significance test. The difference between two proportions in a significance test. Once again, we got to confirm that all these things are greater than 10. Okay, and for confidence intervals, we're going to pool the estimates of the populations. That way we'll get one p, that we'll be able to deal with. So look, using the same information, what you would say is that P1 hat is 463 divided by 615, and 403 divided by 585 is P2 hat. Okay? And that's 0.69. To pool them, you add the 463 and the 403 together and divide it by 615 plus 585, and we get a 0.72. That's kind of halfway in between the two of them there. Okay? So that's the way you pool them together. We need to show that 0.72 times both the populations is greater than 10, and it is, so it's not going to be any problem. We'll proceed on. Okay? So now we find the standard error. The square root of 0.72 times 0.28 times 1 divided by 615 plus 1 divided by 585. This is slightly different in the formula, isn't it? Because we're not dividing the P1 times 1 minus P1 divided by the population. We're actually multiplying those two together and then multiplying it times 1 plus and 1 plus 1 plus. That's slightly different in the way we do this. Okay? Our standard error is 0.26. So our null hypothesis is that P hat 1 and P hat 2 are the same. They're going to be equal. Our alternative hypothesis is going to be that P hat 1 is not equal to P hat 2. So at alpha at a 0.05, 95%, right? 0.05, this is a 2 proportion z-test. So on a calculator, when I key these things in, I get a z-value of 2.47 or a p-value of 0.13. So what we're looking at here is, since this 0.13 is less than our alpha that we had, there's insufficient evidence to support H0. So the perception in the two cities is not the same. That's the way you would do the hypothesis testing there. Okay? Cool. I do appreciate you guys letting me know that you're in AP Statistics when you send questions. You're doing great. We're approaching the end of the course, and the AP test is coming up soon. So I hope you guys have everything all taken care of, and you're ready to go on those tests, and you're ready to go on making a good grade on this course. I look forward to seeing you next time.